Hi, welcome back to part 2 of the second lecture on study design and analysis in epidemiology. We will now move on to describing randomized controlled trials and their design. Before we do, let's remind ourselves where part 1 ended. In the first study, the goal was to estimate the effect of the treatment on mortality. But this could not be done reliably because of confounding. Confounding occurs when there's a backdoor path between the exposure and the outcome. One way of avoiding this, at the study design stage already, is to use a randomized controlled trial, or an RCT. We will begin by focusing on the word randomized. In an RCT, there is randomization of treatments. This means that we randomly assign participants to one of the treatment groups. That is, what treatment a person receives depends only on chance. This ensures that the treatment assignment is independent of all possible confounders. The groups are essentially the same with respect to all variables, or rather with respect to the distributions of all variables, and the groups differ only by chance. This means that the only difference between the groups is in what treatment they receive. It is still possible, theoretically, that you could get unlucky with randomization and still end up with, for example, relatively more young people in one group. However, the likelihood of this happening decreases as the sample size increases, and one can still choose to control for possible confounders at the analysis stage. In our example, we spoke about age as influencing treatment choice, and age also impacting mortality. If we randomly assign whether a person gets the treatment or not, we remove the path from age to treatment, because we don't consider age in our assignment. This means, if age were the only confounder, when we analyze the data, the association that we measure between treatment and mortality is the impact of treatment on mortality. If we randomly assign the treatment, we remove all arrows going into treatment, and we are able to estimate causal effects. So we've spoken about the randomized part of randomized controlled trials. This refers to randomization. Now, let's talk about the controlled part. Returning to our second study, we were unable to answer, was the reduction in symptoms due to the treatment? What can we include in our study design to help us answer this? It would have been really useful if we had a group of participants, also observed over 6 months, that did not have the treatment. When we do RCTs, we need a suitable control group or arm for comparisons. And there are ethical considerations when defining your control arm. For example, we cannot provide people a treatment that we know is inferior to the standard of care. Achieving effective comparison arms may involve the use of masking and placebos. Knowing the treatment assignments may lead to a biased, often but not always inflated, estimate of the treatment effect. This is because participants or evaluators may be biased in their reporting or measuring of outcomes given their knowledge of treatment. As an example, let's consider the flu shot and whether the flu shot protects a person from having flu. It might be the case that those who have had the flu shot are more inclined to dismiss symptoms as tiredness or a cold, whereas those who did not may be really looking out for and reporting every symptom. This would lead to an inflation of the protective effect of the shot. Something quite different might occur. For example, perhaps those who did not have the shot become more cautious about their exposure, knowing that they are still at higher risk, and so they quickly protect themselves when people in their networks have flu. This behavioral change will lead to a dampening of the effect. Another example is looking at the impact of a new nicotine replacement therapy on smoking cessation. Evaluators who are excited about the new therapy may reach out to participants using it to ask them whether they've quit and encourage them to do so. This encouragement may help more people quit smoking, and here we would have an inflated effect. To try to reduce these biases, we can use masking. Masking or blinding is when participants and sometimes evaluators do not know the treatment assignment of participants. There are different types of blinding. In a single-blind experiment, the participants do not know the treatment assignments. In a double-blind study, the evaluators also don't know the assignment. And in a triple-blind study, the data analysts don't know too. A placebo is a treatment that has no therapeutic value, but that resembles and is administered in the same way as the treatment being tested. For example, in the smoking example, a patch that is of no therapeutic value could be used in the control arm. This assists with masking, but it also accounts for the placebo effect. Suppose a treatment has no real value. You don't know this, so you are testing it. For the participants, the belief that they are treating something causing them discomfort, or that they are in some way empowered by participating in the study and having access to an intervention, could improve their outcomes. For example, the belief could translate into physiological changes in the body to improve outcomes, especially for conditions such as depression. So you want to have this placebo effect occurring in both arms to improve comparability of the arms. It is not always possible or ethical to mask the treatment. For example, if the treatment is a surgery, it would be unethical to operate on people in the control arm unnecessarily. Let's talk through a simple randomized controlled trial. We have our population of interest. We sample our study participants, for example, through simple random sampling. And once we've got our study participants, we can use a randomizer to decide on the treatment per participant, here treatment A or treatment B. We can then measure the outcomes, and we can attribute any difference in outcomes to the difference in treatment. This is not the only design of a randomized controlled trial. This is just a simple one. There are many different study designs. For example, if we are considering the treatments, maybe there are many arms. Or one could use a crossover design where a person first receives one treatment and then another. Thinking about how we apply the interventions and collect data, we could have multi-site studies. We could also have community-level designs. For example, if we're looking at the impact of increased fluoride in water supplies on dental cavities, or the use of media to encourage condom use on the impact on HIV, we would need to apply these treatments and measure outcomes at a community rather than individual level. Looking at the randomization could be implemented in other ways too. For example, with stratified randomization, treatments are randomized within groups of participants. With block randomization, participants are randomized in small blocks to keep the number of people in the arms balanced throughout the enrollment process. There are also different phases of trials as we learn more about what we are investigating. Today we've just discussed a simple RCT. We have already mentioned ethics a couple of times, but coming back to this topic, ethics is central to the purpose and design of clinical trials. This may seem obvious, but ethics in medical research is newer than you probably think. If you take a look, you will find many shocking examples of unethical trials. An infamous study is the Tuskegee study. The purpose of this study was to observe the natural progression of untreated syphilis in rural African American men, under the guise of providing free health care. National public health agencies and bodies called for and supported the continuation of the study until completion, that is, until all subjects had died and been autopsied. It was only in 1972 that the study was stopped due to public outcry. Research involving human participants must meet institutional, national, and international ethical requirements. Oversight bodies such as IRBs and DSMBs help ensure studies are conducted safely and responsibly. An IRB, or Institutional Review Board, is a committee that reviews study protocols before the study is started to ensure ethical conduct, including protection of participants' rights, risks, and consent processes. A DSMB, or Data Safety Monitoring Board, is an independent group that monitors accumulating trial data during a study to ensure participant safety, and it can recommend modifications or stopping a trial if concerns arise. Ethical requirements and oversight bodies are guided by key frameworks, such as the Declaration of Helsinki and the Belmont Report. The Declaration of Helsinki is a widely accepted statement of key ethical principles for research on human subjects, and the Belmont Report forms the basis of ethical decisions in the USA. Another central ethical principle is informed consent. Participants must voluntarily agree to take part in a study and continue to take part in the study with a clear understanding of the potential risks and benefits and a clear understanding of what participation involves. Obtaining consent is not always as straightforward as it seems. In practice, comprehension can be limited by, for example, language, literacy, and health. It may sound like randomized controlled trials provide the perfect study design. This is not the case. RCTs, as with other studies, can have their limitations, and estimates may be biased and contain variability. We will talk about this in part 3. When you're ready, please join me for the third video.